Okay, students, so here I will review electric field and its properties. So we said that electric field, we have two charges. We have a positive charge, we have a negative charge, and we said that electric field lines, they exit radially outward from a positive charge. What do we mean by radially outward? And they form an angle of 90 degrees with the surface. And they enter a negative charge radially inward. So this is a negative charge. Field lines will be going radially inward. So we said that to find electric field due to 1 point charge, we have the following equation. So let's say that we have a charge that has a magnitude of Q and a point P which is at a distance of R away from that charge. So we'll have the following. You would say that electric field at point P is equal to the following. It's equal to K times magnitude of Q, and we're using absolute value, so we ignore the sign, divided by its distance squared. So I'll do this example as a demonstration. So here we need to do two things. First thing, we are asked to find electric field at point B, and then they want us to find the force if I put a proton at point P. So let's do that. So let's find electric field at point P. So first thing, we look at the following. Q1 is negative, and we know that field lines, they enter a negative charge. So we go to point P and we draw an electric field vector which is pointing towards Q1. We call it as E1. Or if you like confuse it a little bit, you can always consider the point P as a small positive test charge. We know that positive and negative attract, so it means that on a positive, force will be directed towards the charge Q1. Now we do the same thing for Q2. Q2 is positive, so we know that field lines, they are exiting a positive charge. So at point P, the electric field will be pointing away from the positive charge. So let's call this as E2. Then we'll do the following. We need to find the magnitude of E1, and it's given as K times Q1 over R1 squared, which is equal to 9 times 10 power 9 multiplied by Q1, which is 5 times 10 power minus 6, because it says it's microcoulombs, so keep this in mind, divided by the distance between them, which is 3 meters. 3 meters, it's the SI unit of distance, so divided by 3 squared, which will give us the following: 5,000 newtons per coulombs, and it would be to the west. So to the west, we already know that the angle is 180 degrees. How did I know that I have here non-perpendicular vectors addition? If you look at E2, it's not purely on X nor purely on Y. And also, if this angle is 30, then this angle is also 30 degrees. Now let's calculate E2. So we say that E2 is equal to the following. It's equal to K times Q2 over distance 2 squared, which is equal to 9 times 10 power 9 multiplied by 7 times 10 power minus 6 divided by the distance between them, which is 5 squared, which will be equal to 2,520 newtons per coulombs. And now we would look at the direction. If you notice, E2 looks like this, and we have this angle given, which is 30 degrees. So this direction, which is called northwest. So it would be northwest, and the angle from positive x-axis, which is this one, will be 180 minus 30 degrees. or 90 plus 60, because if this is 30, this is 60, 90 plus 60, which will give us 150 degrees. So simply it's 180 minus 30 because it's northwest. So now we already found the angles for both of them. So 150 degrees from positive x-axis. What do we need to do is we need to find the x and y components and find the total x and total y. So we'll do a small table. So we'll say that, okay, we'll calculate the x components over here. We'll calculate the y components over here. So first thing, we start by doing E1 times cosine theta, which is 5,000 cosine of 180, and 5,000 for the y component, we use sine of 180, plus the other one, which is 2,520 cosine of 150 plus 2,520 sine of 150. We add the x components, we add the y components, and finally we get x total and y total. So for the x total, we will get the following. So we'll get that x total is equal to minus 7,182 newtons per coulombs. And since it's negative, معناها it is to the west. And for the y, we will get that y total is equal to 1,260 newtons per coulombs. And since it's positive, it means that y total is to the north. What's the next step? We got x total, we got y total. So we say that magnitude of the resultant electric field, or E net, is equal to the following. It's equal to square root of x total squared plus y total squared. Always remove the negative sign. So it's square root of 7,182 squared plus 1,260 squared, which will be equal to the following. So let me calculate it quickly. So square root of 7,182 squared plus 1,260 squared, which will be 7,292 approximately. So 7,292 newtons per coulombs. After finding E net, we need to find the resultant angle and the angle from positive x angle, from positive x-axis, sorry. So you would say that the angle, or theta, is equal to the following. It's equal to tan inverse y over x, and again we take it as absolute value. So y, which is 1,260, divided by 7,182, which would be approximately 10 degrees. It's 9.95, but I round it up, so it's approximately 10 degrees. Then we need to find the angle from the positive x-axis. So what do? We do the following. We will say that we need to check the quadrant. So here, plus x plus y, first quadrant, second quadrant minus x plus y, third quadrant minus x minus y, fourth quadrant plus x and minus y. So here we keep the angle the same. Here we do 180 minus the angle. Here we do 180 plus the angle. And here we do 360 minus the angle. So since we have minus x and positive y, which is west and north, so it would be the second quadrant because west is over here and north is over here, so it is the second quadrant. So we say that angle from positive x-axis is equal to 180 minus 10 degrees, which is 170 degrees from positive x-axis. This is part A. For part B, they are saying the following. Part B, they are saying if we place a proton at this location, what is the magnitude and direction of force that would be exerted on it? Now, electric field and force, they are related by the following equation. So for part B, we have the following. Force is equal to magnitude of charge multiplied by electric field value. So force is equal to magnitude of charge. They said it's a proton. So what is the charge of a proton? The charge of a proton is 1.6 times 10 power minus 19. And we multiply it by the electric field, which is given as 7,291. 292, which will give us that the force is equal to approximately this value. It's 1.15. I'll round it up to this value. 1.2 times 10 power minus 15 newtons. However, what is the direction of the force? Keep this in mind. If we go back to this original figure, you'll see that if I put a positive and a negative charge, we know that they attract each other. You can memorize it like this. So field lines, they are exiting from positive. So let's say that this is a positive charge, this is a negative charge. We know that field lines are exiting from positive, entering negative. Let's say that we have the same magnitudes. So we draw equal lines. However, regarding the force, we know that the force between positive and negative is force of attraction. So we'll have forces that are directed towards each other. And if you notice, for a positive charge, field lines and force, they are in the same direction. For a negative charge, field lines and force, they are in opposite directions. So here, since it is mentioned it's a proton, we just say that it has the same direction of electric field. So we say force is equal 1.2 times 10 power minus 15 newtons at, we take the same angle of electric field, 170 degrees from positive x-axis. يعني we say it's same direction as field. Let's say in the question I added another part and I told you find the force on an electron. So we basically do the same thing. We will say that force is equal to magnitude of charge times E, which is same thing. For an electron, the magnitude of the charge, it's minus 1.6 times 10 power minus 19. Since we have absolute value, we write it as 1.6 times 10 power minus 19. Then we multiply it by the electric field, which is 7,292. And we'd say also it's equal to the same value, which is 1.2 times 10 power minus 15 in newtons. Now we need to find the angle. We know that the net electric field is at an angle of 170 degrees from positive x-axis. And this is our electric field. We have here 10 degrees and we have here 170 degrees. And we know that the force for an electron will be exact opposite to it. So how do we reach the force? You have two options. Either you minus 180 or you add 180. So you say that the angle is 170 degrees plus or minus or plus 180 degrees. Start by minusing. If I do 170 minus 180, I'll get minus 10. Can I say it's minus 10 degrees from positive x-axis? No. So we would say that it's 170 plus 180, which would be 350 degrees from positive x-axis. So from positive x-axis. طب let's say for example the angle was 220. If I add 180, I would get above the 360, and if I subtract 180, I would get a positive value. So you always like try to get a value that always makes sense from positive x-axis. Yani for example, if I get something as 430 degrees or something that's above 360, then I would go the other way around. معناها I should subtract 180 instead of adding. فkeep this in mind. And that's it.